In this section, we are going to talk about some of the application and use cases for Euclid's division lemma or algorithm. Let's start with one of the example where we want to show that any positive odd integer is of the form 4q plus 1 or 4q plus 3, where q is some integer. Now let's try to prove this using Euclid division algorithm. So let a be a positive odd integer. So let a be a positive odd integer and b equal to 4. Then by Euclid's algorithm, we can represent a as a equal to b multiplied to q plus r, where q is quotient and r is your remainder, where q is greater than equal to 0 for some integer and remainder r will be greater than equal to 0, but it will always be less than b. Now since we know b is 4, that's what we have assumed here, we can say remainder r is greater than equal to 0 but less than 4, which then implies the possible remainders for r could be 0 or 1 or 2 or 3. And hence we can represent a as 4q, where remainder is 0, or a as 4q plus 1, where remainder is 4, or a can be represented as 4q plus 2, where remainder is 2, or a can be represented as 4q plus 3, where your remainder is 3, where q is quotient. So all that q multiplication is a quotient which we have considered here, right? So now, since we got 4 different combinations, now since we have assumed a as an odd integer, therefore out of the 4 combination, a cannot be 4q or 4q plus 2. Why? Because 4q or 4q plus 2 can be divided by 2 and hence they are not odd integers. So what are we left with? We are left with 4q plus 1 or 4q plus 3. And hence any positive odd integer is of the form of 4q plus 1 or 4q plus 3. Let's take one more example. In this example, we want to show that every positive even integer is of the form 2q, and that every positive odd integer is of the form 2q plus 1, where q is some integer. Now let a be a positive integer and let b is equal to 2. Then by Euclid's algorithm, we can represent a as a equal to b multiplied to q plus r, where q is your quotient greater than equal to 0 and r is your remainder, which is greater than or equal to 0, or it is less than b. Now since b has been assumed equal to 2, we will have remainder r greater than equal to 0 or less than 2. And hence the possible remainders for r could be 0 or 1. Now if we consider 0 as the remainder, a can be represented as 2q. If we consider 1 as the remainder, a can be represented as 2q plus 1. That is, if a is of the form 2q, this is an even integer because you can divide it by 2. However, if a is of the form 2q plus 1, then this is an odd integer because you cannot divide this by 2. Hence, any positive integer can be either even or odd and can be represented as 2q or 2q plus 1. Now let's take some more example. Let's assume I'm in class 10, or let's assume in class 10 you have two sections A and B, so that section A has 18 students. However, section B has 27 students. Now you have to find biggest possible team size in each class with exactly same number of students in each team, so that we can select final team from section A and section B for the final match. So you have two classes, section A, section B. Section A has 18 students, section B has 27 students. Now you create teams from section A and let them have match within section A group. You create another group of team in section B and let them have match together. Whoever is winner in section A and whoever becomes winner in section B will then finally fight for the final match and become the winner. So here is an example, right? So if you try to visualize this in picture, you had section A with 18 and you need a winning team from section A. You had section B with 27 students and you need a winning team for them to play in the final match. If you observe carefully, you can see section A can be divided into two teams with 9 students in each team. 9 plus 9. If you observe carefully, section B can be divided into 3 teams with 9 students in each team. So a careful observation between section A and section B helps you to understand you can have 2 teams in section 1 and they will have 9 students in a team, and you can have 3 teams in section B and they can have 9 students in each team. Now if we extend, and hence the answer is 9 students per team. Now if we extend this problem and make it a little bigger, where section A has 204 students and section B has 255 students. And if I ask you to do the same, then observation will not help, because there's a big number. You cannot really do an observation here, and hence HCF plays very important role here. Remember, HCF of 2 or more integer is the largest positive integer that divide each of the integer. So I have to find a largest positive integer here, right? Now we can use Euclid's algorithm to find HCF of 204 and 255, where 255 can be represented as 204 multiplied to 1 plus 51 as remainder, and since remainder is not 0, I move to the next step of 204 can be represented as 51 multiplied by 4, and in this case you'll get remainder as 0, and hence HCF of 204 and 205 is 255 is 51, and hence the answer will be 51 student team from each class need to be made. Thanks for watching. You can visit us on www.classisfun.com.